In this video, I'll consider one numerical on Laplace transform. Find Laplace transform of the waveform shown below. This is the given waveform f of t. We need to calculate Laplace transform of this waveform. So here in this waveform, we can observe that at t equal to 0, there is one step signal having magnitude 1. That is, this is the step signal having magnitude 1. Let that be my first signal f1 of t. So f1 of t is a step signal having magnitude 1, which will be like this. That is, so this is f1 of t, and this is a step signal whose magnitude is 1. So I can write f1 of t is equal to u of t. Now here we can observe that at t equal to 1, the height of the signal or magnitude of the signal is 2. It means here we have 1. We need to add one more step signal to this signal to get the magnitude as 2. So we need to add one positive step signal at t equal to 1 of magnitude 1. That is, we need to add one more positive step signal. Let that be my f2 of t. That is, this is f2 of t. Say this is 1. We need to add the magnitude is 1. So at this point, when magnitude here it is 1 plus 1, it will become 2. So I can write f2 of t as, it is shifted version of u of t. That is, u of t minus 1. So when we add f1 of t with f2 of t, now the resultant signal will be like this. So this will be the resultant signal when we add f1 of t with f2 of t. But further here we can observe that at t equal to 2, again the magnitude of this step signal will become 1. So to bring this signal to 1, we need to subtract 1 from this signal. It means we have to add one negative step signal at t equal to 2. Let that be my f3 of t. That is, we have f3 of t, that is a negative step signal at t equal to 2. That is, say this is 2. At t equal to 2, we should add one negative step signal of magnitude minus 1. So I can write f3 of t is equal to, here its magnitude is minus, so it is minus, begins at t equal to 2. It means it is shifted version of step signal. That is u of t minus 2. So upon adding f1 of t plus f2 of t plus f3 of t, the resultant signal will be like this. This will be like this, and here it will go down, and this will be continued till infinity. So this is the resultant signal. But here we can observe that at t equal to 3, again signal comes back to 0. So it means at t equal to 3, again we should add one negative step signal. That is, we have to subtract 1 from, we have to subtract this from minus 1, so it will become 0. So I can add f4 of t at t equal to 3. Let that be my f4 of t. So this is my f4 of t, which is at t equal to 3. We should add one negative step signal. Its magnitude is minus 1. That is, plus 1 minus 1 will become 0. So I can write f4 of t is equal to, it is minus u of t minus 3. That is, upon adding f1 of t, f2 of t, f3 of t and f4 of t, will get this original signal f of t. Now therefore I can write f of t as f1 of t plus f2 of t plus f3 of t plus f4 of t. Or I can write f of t is equal to f1 of t is u of t plus f2 of t is u of t minus 1. That is u of t minus 1. f3 of t is minus u of t minus 2 minus u of t minus 2 and f4 of t is minus u of t minus 3. That is minus u of t minus 3. So this is the f of t signal. Now we need to take Laplace transform of f of t, that is taking Laplace transform of f of t, we get, so Laplace transform of f of t is f of s, which is equal to Laplace transform of u of t is 1 over s plus Laplace transform of shifted version. It can be represented as 1 over s e power minus s minus Laplace transform of this will be 1 over s e power minus shifted by 2 in it. We have to apply shifting theorem. It will be 2s minus this will be 1 over s shifted by 3 in it e power minus 3s. Or I can write f of s is equal to 1 over s. We have 1 plus e power minus s minus e power minus 2s minus e power minus 3s. So this is the Laplace transform of given function f of t. Thank you for watching.